Read the question carefully. So basically we have an object of mass 10 kilogram at the height of 60 meters from the ground, and which is being thrown towards the sky vertically up, and we need to assume it, when it drops, it misses that cliff and goes to the ground. So we start from here. So initial position here, so let's assume initial height be 0, and we are assuming going downward is positive. Okay, downward motion is positive. So the velocity initially is going up, so initial velocity it says 10, but it should be negative because of our convention. Okay, because downward is positive, so this is going up for now, so negative 10. And this is initial height, and the ground will be the height at after some time, we don't know, it will be 60. So 0 and downward 60. Okay, so in this case we have basically two motions, going up and down. Going up means velocity will be negative, going down that will be positive. But we just set up one equation for first part, going up, and that will take over everything. And that is given by Newton's second law of motion. The force is mass times acceleration. So we have mass times acceleration, dv over dt, is equal to, so it's going up, there are two forces acting downward. Weight is mass times acceleration due to gravity, g, which happens to be 9.8 meter per second square, positive because it's going downward. And plus another force is the air resistance, okay, plus 2 absolute v, but v is negative, and absolute value of negative number is negative, so negative 2v, so that the whole thing will be positive. Now we divide both sides by m, so we get dv over dt equals g minus 2 over m. M is 10 kilogram, so 0.2 v. Now we solve this differential equation. This is g equals 9.8. Let me move this to the left. So dv over dt plus 0.2 v equals g 9.8. This is a linear in v with respect to t. So we find the integrating factor e raised to 0.2 dt, which is e raised to 0.2 t. Multiply both sides by this integrating factor, then the left hand side automatically becomes derivative of dependent variable v times exponential integrating factor equals 9.8 times e raised to 0.2 t. Now integrate both sides with respect to t, we get v times e raised to 0.2 t equals integrate, so exponential function itself divided by 0.2, so 9.8 divided by 0.2, that's 49 e raised to 0.2 t plus constant of integration. Now divide both sides by this integrating factor e raised to 0.2 t, so v is isolated now, v is in fact a function of t, equals divide, so this is gone, just 49 plus c over this exponential, c over, move that up, so c times e raised to negative exponent 0.2 t. Now using the initial condition, because the v0 is negative 10, okay, initial height is negative 10, and we from that we can find the value of c. So using v0 equals negative 10, this is negative 10 when time is 0, so this is 49 plus c, e raised to 0 is 1, so c equals subtract 49, so that's 59, negative 15 minus 59, substitute here, so we get the velocity at any time t is 49 minus c is minus 59, so minus 59 e raised to negative 0.2 t. Let me write number 1, equation 1 for future reference. Now this is the velocity, which is rate of change of position or rate of change of height. If we integrate one more time, then we get the height. Okay, let's do that. integrate both sides with respect to t, then we get height equals antiderivative of 49t minus, this is 59 e raised to negative 0.2 t divided by negative 0.2, and negative negative positive, and this becomes 295. Okay, when divided by 0.2, e raised to negative 0.2 t plus some constant of integration, let's say d. And let's use the initial height. Initial height was 0. We just assume this is 0 position, so s0 equals 0 to determine d. So using s0 equals 0, we get 0 equals 49 times 0, 0. 295 times e raised to 0 is 1, so 295 plus d, and that gives d equals, move over, negative 295. Substitute negative 295 for d here, then we get the height or position at any time t, st, is given by 49t plus 295 e raised to negative 0.2 t plus d is negative 295. So let me say equation 2 for future reference. Now we have the velocity in equation 1. Velocity at any time t is given by this equation, and equation 2 is the height or the position height at any time t. Let's go back and read the question and see what is being asked. So determine the velocity, okay, of the object when it hits the ground. So when it hits the ground, we need to know the time first, how long it takes to go to the ground. Once we have the time, then we plug in that time to the velocity equation, which is equation 1. So we need to know the time, and we know that for ground the height will be 60 relative to this. So we set the height equals 60 and solve for t. Then once we have t, we plug that into the velocity function and find the velocity. Okay, so let me go down here. So now we set the height, equation 2, height equals 60 to determine the time needed to get to the ground. Set the height st equals 60, then this is 60 equals, okay, we don't know t, we are trying to find t, 49t plus 295 e raised to negative 0.2 t minus 295. So this is linear and exponential, so we need to solve. Let me move 49t and 295 other side and leave this 295 exponential in one side. So 295 e raised to negative 0.2 t, that middle term, equals, move this over, okay, this is here, so when we move, this is 60 plus 295, that's 355, and move this over, minus 49t. Okay, we need to solve this. So algebraically it's impossible because it's exponential and linear. So we need to graph this function, and find the point of intersection, and that gives t. For these are big numbers, let's divide both sides by 49. Okay, 49 is the number here, so divide both sides by 49, then 295 divided by 49. Okay, so that will be 6.02 e raised to 0.2 t equals 355 divided by 49, so 7.245 minus 49t or 49t. Now we're going to graph this equation, and find the t, that means the x value in the graph. Okay, so let me go over here and bring the calculator. So I already entered this function here, and that function is y2, and we graph. So this will be straight line, and this will be curve. This curve and this is straight line. By the way, they intersect at two places. On the left, that's negative time, so we don't consider that. Just look at this. So let's find that. So go to calc. So second trace, then go to intersect number 5, enter, and select the first curve, go closer to the intersection point, so move, that's the first curve, okay, exponential, yes, enter, and second curve, yes, enter, and guess, enter. So it gives you X value 5.05. So that's our T, 5.05. Okay, so it takes 5.05 seconds to get to the ground. Now we need to find the velocity. For that, plug this into equation 1. Then by equation 1, just plug in there. Okay, velocity after 5.05 seconds is given by, just plug that T equals 5.05 in equation 1. Then you get 27.5 positive, obviously going down, so meters per second. Final.